Welcome to my channel, Simple Ways to Learn Statistics. Myself, Sandesh B, lecturer in statistics. Today's topic is theoretical distribution. In the earlier video, I discussed about the Bernoulli and binomial distributions. Today, in this video, I am discussing about the Poisson distribution. So, French mathematician Simon Denis Poisson in the year 1837 derived a limiting form of the binomial distribution, which is called as the Poisson distribution. This distribution may be obtained under the following conditions. The number of trials n is indefinitely large, that is n tends to infinity. The constant probability of success for each trial p is indefinitely small, that is p tends to 0, and np is equal to lambda, a constant. Then the definition of the Poisson distribution, if x is a discrete random variable with probability mass function, probability of x is equal to x, that is equal to e power minus lambda lambda power x by x factorial, x is equal to 0, 1, 2, etc. infinity. Then x is a Poisson variate and the distribution of x is called the Poisson distribution. Then the examples of the Poisson variate are number of deaths occurring in a city in a day, number of road accidents occurring in a city in a week, number of incoming telephone calls at an exchange in 1 minute, number of printing mistakes per page in a textbook. These are some examples for the Poisson variate. In all these examples, number of trials are large, that is n tends to infinity, and probability of success is very small, p tends to 0. Therefore, np is equal to lambda. Then, the features of the Poisson distribution. In the earlier video, I discussed about the Bernoulli and binomial. In that also, the first 5 features of the Bernoulli and binomial are in the same order. Here also, the features of Bernoulli, binomial, and Poisson are in the same order, but not the same. That should be in the same order. Then, the first feature is Poisson distribution has only one parameter, that is Poisson distribution is uniparametric distribution. X is equal to 0, 1, 2, etc. infinity is the range of the Poisson distribution. Then third one, the Poisson distribution, the PMF is probability of x is equal to x, that is equal to e power minus lambda lambda power x by x factorial, x is equal to 0, 1, 2, etc. infinity. Here is the exponential value. Then in the range, we consider x is equal to 0, 1, 2, etc. infinity. But this is not 0 to infinity. This should be 0, 1, 2, etc. infinity. What is the difference between 0 to infinity and 0, 1, 2, etc. infinity? There is a lot of difference. So 0 to infinity means the x can take all the values in between 0 and infinity, including the decimals. There is a continuous. But Poisson distribution is a discrete probability distribution. X is a discrete random variable. That means only takes the specified values of a given range. Therefore, here x can take only the specified values, that is 0, 1, 2, etc. infinity. That means only the whole numbers. Then the next feature is Poisson distribution. Mean is equal to lambda, variance is equal to lambda, and standard deviation is also equal to lambda. Then the relation between mean and variance in the Poisson distribution, mean is equal to variance. That means the mean and variance are equal for a Poisson distribution. When lambda is not an integer, if in case lambda is not an integer, that means lambda, for example, the lambda value is 2.3 or 3.1 or 3.4 like this. That means that is not an integer. Poisson distribution is unimodal distribution. The integral part of lambda is the unique modal value. Already I told that the lambda is not an integer. That means if lambda takes the value 2.3, that means 2 is the integral part, 3 is the decimal part. 3.1, 3 is the integral part, 1 is the decimal part. 3.4, 3 is the decimal integral part, 4 is the decimal part. Here we consider integral part of lambda is the unique model value. In the first case, 2.3, 2 is the mode value, 3.1 and 3.4, the 3 is the model value. If in case lambda is an integer, Poisson distribution is bimodal. If lambda is an integer, Poisson distribution has two model values. One is lambda minus 1 and other one is lambda. The integer means if lambda takes the whole number, lambda is equal to 3, then the modes are 2 and 3. If lambda is equal to 4, the modes are 3 and 4. Then Poisson distribution is positively skewed. That means beta 1 is equal to 0. Poisson distribution is leptokurtic, beta 2 greater than 3. So Poisson distribution is positively skewed, beta 1 is greater than 0. Poisson distribution is leptokurtic, beta 2 is greater than 3. Then the limiting form of the Poisson distribution, normal, is the limiting form of the Poisson when lambda is very large. If lambda is very large, Poisson converges to normal distribution. We consider that to be normal distribution. So these are the some properties of the normal distribution. Yes, we consider some of the problems based on the Poisson distribution. The first one, a typist makes two mistakes per page on an average. Find the probability that a page typed by him has two mistakes. Second one, at the most two mistakes. Here in the problem, they are asking about to find the probability of the mistakes. That means we need to define x. X denotes number of printing mistakes. Then on an average, two mistakes per page. Average means lambda. Lambda is equal to 2. If they are given lambda, that means x follows Poisson distribution. Once the x follows Poisson distribution, then probability mass function, probability of x is equal to x, that is equal to e power minus lambda, lambda power x by x factorial. X is equal to 0, 1, 2, etc. infinity. Then probability of x is equal to x, that is equal to e power minus 2, 2 to the power x divided by x factorial. Here x can take the value 0, 1, 2, etc. infinity. That is equal to e power minus 2. The value of e power minus 2 is obtained from the table value. So the table value is, yes, here we consider the e power minus lambda value by this table, that is a Poisson distribution exponents. In the first column, the value of lambda, that is lambda, can take the value 0, 0.0, 0, 0.1, 0, 0.2, 0, 0.3, 0, 0.4, etc. 11 point, that is the second digit or the first digit. Here 0 point ಅಂತ ಕೊಟ್ಟಾಗ first digit ಅಲ್ಲೇ ಕೊಡ್ತಾ ಹೋಗಿರ್ತಾರೆ, we consider the second digit in the column. But 1 point, 2 point, 3 point ಎಲ್ಲ ಬಂದಾಗ we consider the first digit after the point, first digit is considered in the column. Here we need the value of 2.2, that means 2.0. Here 2.0, that is 0.1353 is the table value. Yes. So here e power minus 2, the value of e power minus 2 is 0.1353 into 2 to the power x divided by x factorial. Here x can take the value 0, 1, 2, etc. infinity. Then this is the sum simplified form. We go with the first question, that is probability of, they are asking probability of x, two mistakes, x is equal to 2, that is equal to 0.1353 into 2 to the power 2 divided by 2 factorial, that is equal to 0.1353 into 2 to the power 2 is 4 divided by 2 factorial is 2. That is equal to, if we simplify these values, then we will get the value 0.2706. This is the first one. Then we go with the second. That is at the most two mistakes. At most means probability of x less than or equal to 2. That is equal to probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. Here, in the Poisson distribution, the first probability term is always taken as probability of x is equal to 0, that is same as e power minus lambda. That is equal to e power minus 2. We are already getting the value from the table, that is 0.1353. Then one more term, that is probability of x is equal to 1. Here we can apply the recurrence relation between the two probability terms, that is lambda by 1 into probability of x is equal to 0. That is equal to, here lambda is 2, 2 by 1 into 0.1353. We substitute these values, x is equal to 0, that means 0.1353 plus probability of x is equal to 1, that is equal to, here we need to solve another term, that is 0.2706, 0.2706 plus x is equal to 2, that is also equal to 0.2706. So that is equal to 0.6765. So this is the probability of x less than or equal to 2. So that means that this is the first problem we consider for finding the probability values in the Poisson distribution. This is the first one. Then go with the another problem. On an average, if a telephone operator receives 3 telephone calls per 5 minutes interval. Here, X denotes number of calls received by the telephone operator. Yes. So here on an average, there's a 3 telephone calls. That means lambda is equal to 3. Then X follows a Poisson distribution. Probability of X is equal to X, that is equal to e power minus lambda, lambda power X by X factorial. Here X is equal to 0, 1, 2, etc. infinity. Then we go with e power minus 3, 3 to the power x by x factorial. Here x can take the value 0, 1, 2, etc. infinity. Then e power minus 3, the same procedure from the table value. So if we consider the table value from the table e power minus 3, that is, consider the term 3.0, that is 0.0498 from the table value, that is from the Poisson distribution exponents. Yes. From the table, e power minus 3, that is equal to 0.0498 into 3 to the power x divided by x factorial. X can take the value 0, 1, 2, etc. infinity. Then we go with the first one, that is does not receive any call. Here that does not means we consider probability of x does not means there is 0 calls. X is equal to 0, that is e power minus lambda, that is equal to e power minus 3, that is equal to 0.0498. Then we go with the second one, that is receives more than one call. That means more than one means x greater than 1. But here we consider the Poisson distribution. The range of the Poisson distribution is 0, 1 to etc. infinity. That means greater than 1. That means x can take the value 1, 2, 3, 4, 5, 6, etc. up to infinity. Therefore, that is not possible to solve the problem. Then we go with the complement of this method. That is 1 minus probability of x less than or equal to 1. Here consider more than 1. If they given that more than or equal, then greater than or equal to 1 we consider. But more than 1, that means only x greater than 1. Complement 1 minus probability of x less than or equal to 1. That means 1 minus probability of x is equal to 0 plus probability of x is equal to 1. Yes. So already we know that the probability of x is equal to 0. Then we go for x is equal to 1. We need to calculate the value of x is equal to 1. That is probability of x is equal to 1. That is equal to lambda by 1 into probability of x is equal to 0. That is lambda is 3. 3 by 1 into 0.0498. The complete value is 0.1494 for x is equal to 1. Then we will substitute these values in the equation, that is 1 minus x is equal to 0, that is 0.0498 plus 0.1494, that is equal to 1 minus 0.1992. Then we will get the value as 0.8008. So this is the solution for the second problem. Then we go with the third one. It has been found that on an average, 4 patients visit a particular doctor during 1 hour. What is the probability that during a particular hour, the doctor is free? More than 3 patients visit the doctor. Here also, x denotes the number of patients visit a doctor. Then, on an average, 4 patients, lambda is equal to 4, x follows Poisson distribution. Then, probability of x is equal to x, that is equal to e power minus lambda, lambda power x by x factorial, x is equal to 0, 1, 2, etc. infinity. Then that is equal to e power minus 4, 4 to the power x by x factorial, x is equal to 0, 1, 2, etc. infinity. Then e power minus 4. From the table value, the e power minus 4 is equal to 0.0183 into 4 to the power x by x factorial, x is equal to 0, 1, 2, etc. infinity. Then we go with the first one. The first one, probability of x. The doctor is free. Doctor is free means there are no patient. There is probability of x is equal to 0. E power minus lambda, that is same as e power minus 4, that is equal to 0.0183. But the second one, there is more than 3 patients visit a doctor. So more than 3 patients, there is probability of x greater than 3. That is equal to 1 minus probability of x less than or equal to 3. I already told that. So x less than or equal to 3, that means 1 minus probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3. These are the terms. Then first we need to find the value of 0, 1, 2, 3. Probability value for x is equal to 1, x is equal to 2, x is equal to 3. Because 0 already we calculated. Then probability of x is equal to 1, that is equal to lambda by 1 into probability of x is equal to 0. Lambda is 4 by 1 into 0.0183, that is equal to 0.0732. Then probability of x is equal to 2, that is equal to, sorry, lambda by 2 into probability of x is equal to 1. 4 by 2 into x is equal to 1 is 0.0732, that is equal to 0.1464. Then probability of x is equal to 3, that is equal to lambda by 3 into probability of x is equal to 2, lambda, that is 4 by 3 into 0.1464, that is equal to 0.1952. These values are substituted in this equation, above equation. We get the value that is equal to 1 minus, I directly give the answer, that is 0.4331, that is equal to 0.5669. So this is the answer for the second question. This is the second part. Yes. Yes. So these are the three problems we already we are discussed in this video, and the remaining problems will be discussed in the another video. Thank you.